It's been a while, but we've got some fun jobs to do. Let's get stuck into it. Before we get into any work, there's two things I need to tell you. So number one is I'll be at the Melbourne 4x4 Expo only on the Saturday and the Sunday. So that's the 24th and 25th of August. I'll be hanging out with Tyler Thompson on his stand, helping out a little bit and just generally floating around, talk a bit of rubbish. I will have a couple stickers there, so come and check them out and grab some, but I am looking forward to that. And the discount code at Roadrunner Off-Road is still running. So if you're looking to purchase anything from Roadrunner, chuck in the discount code and that will save you a little bit of cash. So it's actually been quite a while since I've even touched this car. It's a little bit frustrating, but everything's been so busy that I just haven't had 2 seconds to even look at it. Since you've last seen it, it's actually been to the panel beaters. So Steve down at Custom and Classic Revival in Maui worked his magic. So it's probably gonna have to go to him a few times. Like the whole cab's obviously gonna eventually get resprayed. The engine bay will get resprayed. But this particular time I went there to have the roof fixed. So there was some rust and bog and that in the roof that I wanted repaired. And it turns out that the roof skin was not really salvageable. So I had to find another roof skin. I got quite lucky with that, but I did find one. So there's a new roof skin on there. It's all nice and clean. There's no bog in it. He did a couple cheeky mods while he was in there for me. An idea that I've had for a long time now, many years. So we'll get into that a bit later on. And he also replaced both sills. So the left one was punched in and the right one had a couple dints in it. So instead of trying to repair it or replace a sill with another factory Nissan sill, he just folded up some, I think 2mm bits of steel and welded them all back in. So the sills are a little bit stronger now, a little bit more resilient to dints. Even though it's going to have rock sliders on them, you still get the occasional dint in the sill. So he actually filmed a few videos and took a few photos of the whole process. So I'll make a bit of a montage and throw that all together, and you just can get a rough idea on the amount of work he's already put into it. So as you can see, he's done a brilliant job with that. So he hasn't done any like final work, like any filler work or anything like that. It's literally just welded up, ground back and sort of cleaned up, and then it's just in primer. So that will obviously get painted right at the end. And you may have noticed the little cheeky mods that he's done. So there's 5 holes in each side. We'll get into that a little bit later in the video and why I've done that. And we'll see if it was actually worth the effort. So this video is going to be a little bit of fun stuff. We're going to get the tube bender out and make some cool stuff. I was waiting on two things and I wasn't sure when they were both going to get here, but they both got here roughly at the same time. And one's to do with the headboard and the other one's to do with the front end. But I still need a couple more parts for the front end, but that is coming very soon. So front end and suspension and some other cool stuff's going on there. So for now, we'll get this headboard done. I'm gonna make it a twin tube headboard, and then I wanna do roof sliders, and then I also want to do some tube work on top of the roof between the roof sliders, and I've got a light bar to mount up there and all sorts of other cool stuff. So enough yapping, let's do some jobs. So to start this headboard, we need to make some chassis mounts. I've already actually drawn some up. I just need to cut them out and then fold them. But because there's gonna be a twin headboard mounted to the chassis, I'm gonna have plates and bolts and whatever. It's gonna be quite strong. So what I have to do is cut this tray mount off. It's in the way anyway, but it's not necessary because the tray will mount off the headboard, obviously. So this tray mount's gonna go. This tray mount will stay, and the very end tray mount will stay, but this one will get cut off eventually as well because it'll interfere with the guards and everything else. So I wanna try and keep 2 tray mounts per side, because then that gives you a good reference across the whole back to build the tray off. So I've already cut the other side off and cleaned it up. It wasn't fun. I'll cut this side off and then we'll start with the fun stuff. So I'm still just using the basic 2D CAD program. I haven't transitioned into Fusion yet. I haven't had time. So this is the weld-on plate. As you can see, it's fish plated on all the ends. I don't want vertical or straight welds on the chassis. These little holes are going to be threaded holes, and the bolts are obviously going to thread into them. And then these bigger holes are exactly where the tube's going to sit, but these are only 25mm holes, and I'll weld them like a plug weld onto the chassis, and then the tube will go over the top, which is 45mm. So I have put a relief slit in here because it's going to be 10mm plate. I want to try and fold it, and so I just put a big relief slit, and hopefully that means I can fold it. And this will be the plate that goes over the top that the tubes get welded to. So these 3 big holes are exactly where the tube will go, but I'll delete them. They're just there for reference. Square edges on this piece doesn't matter because it's only a bolt-on section. So we'll jump across to the table and start cutting. All right, so the mounts are finished. I just ran a weld down the inside of the 10mm, and then I couldn't quite get the fold right on these outer pieces, so I just had to cut and weld them too, which is no big deal. I just couldn't fold it perfectly to make all 5 bolt holes line up. It was pretty tricky. I've trimmed the bolts down like they're ready to weld on. So I've welded this temporary piece of angle iron to it because that's where the tube will sit. It just gives me something to rest it on, once it's all bent up. So pretty much all we're going to do is weld these on in place. I'll just do a couple temporary tacks, I suppose, just to make sure everything's right. And then we can start bending some tube. All right, well, I just set the mounts up. So I just had to make sure they're in the same spot, backwards and forwards. So I referenced it off, like the hole in the chassis. The tray mounts are actually 10 mil different, I found out. The body mounts, the body, the long arm bracketry and all that, like just tried to reference as many points as I can. And they're all within, 1 or 2 mil. So the brackets are set up good. And because this face is shorter than I'd like, because of the long arm bracket, like usually I would have ran this further down the chassis and had the tubes come off the center of the chassis, but the bracket's in the way. The radius of this part of the chassis on the corner actually is a little bit tricky to set the mounts up properly because there's not a big enough face. Well, there is, but if you clamp it in the wrong spot, it'll peel the mount up. So I've got this bit of tube running across and I can eye the face of the tube on the face of the mount and make sure there's no daylight coming through, so both mounts are running flat with each other. And then I've got an angle gauge in the center to make sure the mounts are exactly level. So I've referenced the angle gauge on the rear window, the bottom of the cab, the coil brace, the rear of the chassis, and it's all within 0.01 degrees. So all pretty accurate there. So these are clamped on, ready to weld. Well, now that both of these chassis mounts are done, it's time to get into bending this hoop. I was planning on learning a software like BendTech or something to then draw up the whole headboard and the whole tray and even the bull bar and that, draw it all up in CAD just so I can get a visual on it. And also to learn something new. I've never done anything like that. And part of the reason I wanted to build this car was to learn new skills, and that was one of them. But I actually haven't had the time to even buy the software and then sit down and use it. Hopefully by the time I start the tray or something, I'll be able to get a bit of time and learn how to use it. I've only ever bent up one headboard, and that's on the race car. And that was back in 2016, I think. That was one of the first things I ever bent up using a bender myself. So I'm going to use the same method I did for that, which I learned off a friend of mine, Scotty, back in the day. And I thought it would be a good opportunity to show you how to do it without using CAD or anything like that, because that can be a little bit daunting. So we'll get into drawing this up. So as you can see, I've already drawn it up on the ground. So I'll show you the process on how I got to this position. So the first thing you need to do is clear a big work area. And then I used this perfectly straight edge that's been cut into my concrete. Now take your time when you're doing this, double, triple, quadruple check your measurements. Like this is basically just drawn to scale, and I'm gonna use this to measure when I start bending the tube. So this has to be quite accurate. But the first thing you need to do is measure your mounts. So I just hooked on to either mount and measured the width of the chassis from mount to mount and drawn them on the concrete, squaring off my straight line. So I also drew in the top of the mount, and then I actually marked the width of the tube on it. So, because I'm gonna have a vertical off the chassis, so I just marked that, but that will come in handy as well. So next step you have to do is work out the whole width of the headboard. So what I did was I grabbed a bit of tube, and you sort of need to decide how far past the edge of the cab you want the tube to sit. So whether you want the edge of the tube in line with the cab, or whether you want a tube width out of the cab, or that's something that's personal preference. So I've marked this a tube width on the outside. So the outside of the cab will be the inside of my tube, and then I'll have, 45 odd mil protruding past the edge of the cab. So what I actually did to get that width was I sat the bit of tube on the ground and eyed it up between the edge of the cab, and then I took a measurement from the chassis mount to the edge of the tube, and that will give my outside dimension. It's probably worth noting that this whole drawing is to the outside of the tube, not the center line, not the inside, so I'm working to the outside. Because the side of the cab where the doors are is basically vertical, so I know that my bottom bend is going to be 90 degrees. So when you work out the whole width, you need to draw 2 lines at the width, square off your bottom line. You then need to work out your height. So this baseline on the concrete is represented on the car with the pieces of angle iron on the chassis mounts. And I know that the bits of tube are going to sit on them angle iron. So basically I need a measurement from that angle iron all the way to the highest point. So what I actually did was I ran a bit of tube between the chassis. I only had a bit of tube, but a bit of box section would probably be better, or angle iron, between the chassis, because the highest part of the roof is in the middle. I was then able to measure off that bit of tube to the highest part of the roof, and that was roughly by eye. You could put a level on the roof or something and get a gauge like that, but I'm confident enough just to do it by eye. So on that measurement, I think it was 1235. I added the thickness of the tube, which is 45 mil, which brings it to 1280. I then measured from the top of the mount down to the angle iron, and I think that was 75 mil or 80 mil. And now, because my measurement was to the tip of the roof, I now have the measurement from the outside of the tube at the bottom, which is my angle iron, to the inside of my tube at the top. Now, because I want the width of the tube above the roof, I then add 45 mil to my measurement on top of that, and that gives me my maximum height from my baseline. So I can simply measure, I can hook onto that, and I know that the highest point of my headboard is going to be 1380 mil. So because I knew I wanted 6 bends in this headboard, so 1 at the base, 1 halfway up, and then 1 at the roof, I needed to work out what angle this top section of the side will be. So basically I used this little angle gauge on the side of the car and took a few measurements. I had a bit of tube there and basically eyed it up to the side of the cab. And then I worked out the angle that I think would look the best. So we then need to figure out where this middle bend is going to happen on the side. So eyeing up the side of the cab, it sort of changes directions around the body line where the door lock is, in between the door handle and the door lock. There's a body line that runs through, and that's where it visually changes angles. So I put a level with the angle gauge on that body line, and then I reference that back down to my bit of angle line on the chassis mount, which is down there. So that means I was able to get a measurement from the angle line up to where I want the bend to happen, and then I mark that on either side on the concrete. So the next thing you need to do is get a test piece of tube. So what I've done is I've measured exactly 90 degrees on the bender, and I've referenced that with a big square to make sure it's 100% 90 degrees. And then as I went, I marked the increments off the follow or die onto the bit of tube. So I marked 0, and then I just did 30, 60 and 90. And this can also help on the car. You can hold it up and visually have a look on the car, but you need this to draw in your angles on the concrete. So this is important to mark the bit of tube off the die on the bender that you're going to be using to bend this whole headboard up, because different models of benders will have follower dies or your reference point potentially in a different position. So no good having a test piece with markings on it from a different bender, and make sure you're using the correct centerline radius die that you're going to be using for the headboard as well. So essentially this 90 degree bend will be exactly the same as the 90 degrees down the bottom. So now that we've got our chassis, our vertical side measurement and our top measurement, we can then fill in the blanks using this test piece die and the degree we worked out for the bend that's halfway up the sides, which was 13 degrees in this particular case. So basically we grab our test piece, we line it up with our straight bottom piece, which is the line in the concrete, and then we line it up with our vertical mark that we put in place for our maximum width. We're then able to transfer the 0 degree mark onto the concrete and then the 90 degree mark onto the concrete. And that actually shows the start and finish of the bend as it would be marked in the in this particular die. So when I go to bend up my headboard, I can make the same markings on that bit of tube as well and know that they're going to be a good reference point for the rest of the headboard. The next step is to mark our 13-degree bend. So these tools are very handy. It's a degree wheel with a bit of a ruler on that as well. So, you know, I can set this to 13 degrees, tighten that up. And then what I can do is line this up with my vertical mark and then transfer the 13-degree mark on the other side of the angle gauge. So once we've confirmed this line here with our test piece and our angle gauge, we can then draw that straight line in all the way up to where it intersects the highest point mark, which is up here. And then you'll get a 77 degrees square edge angle in there. And then simply to draw in this top bend, we line up our face with the line we just drew in, and then we push that all the way up to where it intersects our top line, and then we can draw that in. We then now follow the same process and draw in the other side, and you should have all your start bends marked because of your zero on your test piece, and then should be able to measure each side and make sure they're exactly the same off your baseline. And providing we've taken our time and triple checked all of our measurements, it should be a very accurate representation of the headboard. And we can then even accurately measure the length of tube that we need to minimize waste, especially in my case because the stuff I'm using is very expensive. So let's start bending. So this is a JD squared model 32 bender. My brother's owned it for years and I've just borrowed it. So the tube I'm using is actually roll cage tube. It's 1 3/4. I think it's 2.6 wall. The reason I'm using it is I wanted a bit of extra strength in the headboard. Like this stuff's a lot stronger than your normal NB pipe, but it does come with a price tag. So I bought 4 lengths and that's to do the headboard, rear stays and all the roof slider stuff. It cost me over $1,000. So I really do not want to mess this up. And I also want to minimize wastage as well. So I've done a full measurement and I've added 200 mil. So I'm hoping with 100 mil either side. So with them 100 mil offcuts will be infills for the twin tubes in between. So if this all works out, it will be a miracle. So we'll just start at one end. We've got a 90-degree bend, 1377, then 77, 1390. So let's start bending. So that is one full rear hoop done. Everything come up really nice. It's all on the same plane, like there's no rocking on the ground. Actually throw this on the back and see how it looks visually. And then I'll get stuck into bending the next one and then cut all the in-between bits and notch them. Hopefully sit it together as one single piece. 2 headboards all joined together. So then I'll throw it back up and I'll be able to tack it in place. Rightio, so it's time to do some vertical uprights in these and across. Now I want the vertical upright in because if that had a heavy load from the top, you know, these would essentially peel down or push down on the chassis. So having a vertical bar in there makes it super strong. It does mean that, you know, if it did happen to get in a hard rollover, it would probably bend the chassis right here. But, you know, chassis is a little bit easier to find than a nice U cab. So I'd rather try and be able to preserve the cab. And then the cross goes in it to stiffen it all up in case it has a side load, so it doesn't bend or twist either way. So the cross will keep it solid from side loads, and these will keep it solid from vertical loads if that ever happened. So I've just started to utilize this cool little tool. I've got it as a redemption thing when I bought some stuff at Total Tools. It's a little digital measuring device, and it's super accurate. So I've just had a play and I've just measured these verticals, and that gives me an accurate measurement to the millimeter. And I can then see by the measurements that they are within 1 millimeter. So I know the mounts have been welded on properly, and I know this top section is parallel to the chassis. So I suppose we'll do some cutting. And that is a main hoop all pieced together. Apologies about the time lapses. I am sort of trying to get this done as fast as I can because the video is already 2 weeks late now. But I am very happy with how that came up. So it was a little bit tricky to line up the two separate pieces in the cross here. So obviously you have one full length that goes through, and then the other side is half and half. And essentially you have to line that up. So it's all governed by the top point where they intersect in the corner. And then obviously where it's aiming down the bottom, you know, so to try and line up the two center pieces, otherwise it look quite ugly. So I have this piece of angle line that I notched 2 arcs out of for the fixed length piece that's in the cross. It slides over the top, and then yeah, you can sort of clamp the two separate bits of tube to the bit of angle, and that lines it up through the cross. So the last thing we're going to do for this episode is just bend up some roof sliders. So I have done it before, but I'm going to do these slightly different. Now this is where these holes come into play that the panel beater put in there. So they're actually threaded slugs that I've had welded in there. I had them machined up, and they've got a 10mm metric fine thread in them. And the whole idea of all this is I want everything to unbolt. So that's the roof slider and roof cage, you know, the tray will unbolt, you know, sliders bar, everything will unbolt. So this can essentially go back to a bare cab if I wanted to. And also I just wanted to try something different instead of welding to the roof all the time. It'd be awesome for this to work out and it bolt on. So roughly how this is going to work, I've had crush tubes machined up with a countersunk hole for a cap head bolt. And then what I'm going to do is bend up the whole roof slider, the roof cage, the light bar rack, and all the stuff, and try and weld as much as I can. And then I've got to insert these crush tubes into the tube, and these will bolt to the threaded slugs in there, and then obviously welded to the roof slider. So they'll just have a nice little hole in the end with a cap head screw. It should look nice and neat. And I'll probably put a rubber washer on the back side between the crush tube and the face of the body. And then I'll run some very thin, like strip foaming between the roof slider and the cab, just as a bit of a cushion there, so it's not steel on steel. That idea's been in my head for more than 5 years, I reckon. So it's nice to actually bring it to life, and hopefully it works. If it doesn't, well, at least I tried something different. And another idea that's been in my head for probably even longer than 5 years is I'm actually going to run the roof sliders all the way down the pillar, and then I'm going to run them behind the guard. So they will sit behind the guard like that, and then I'll have a bit of a hole in the guard where these will come through, and then I'll probably weld this piece behind the guard. I'll probably weld it to a couple sections or somehow fix it in there, and then I'll put one of these Camberg joiners in the tube here behind, So then that's fixed behind the guard, but then the whole roof section unbolts and can be taken off. So the reason I want to do that is for a little bit of extra strength in the pillar. So usually we run the bars to about there somewhere. And if you had a hit, you know, down the bottom of the pillar here, it could potentially push the pillar in. But by running this all the way past and then all the way down and then fixing it all through here, it gives the pillar a little bit more strength. So you can have a hit down the bottom here and it should hopefully keep the pillar and everything in shape. And it should look pretty cool as well. And the other thing that's going to happen is they're going to join into the rear hoop of the tray. So I'm going to put like a control arm bush and then a bracket coming off the rear hoop. And that essentially is to sort of brace it all. So a chassis will flex a lot and that's what it's designed to do. So if you've seen ute cabs and that before, if you belly out on something real hard, the tray and the cab actually separate quite a lot. Now, if you have like a full 6-point roll cage, this eliminates it because you've got a 4-point in the cab and then you've got rear stays triangulated to the back of the chassis. So that's a lot of added strength. So you sort of don't get that movement. And that's why a lot of ute chassis crack. Like they always crack behind the cab here. There is a joint in the chassis there, but also it doesn't help that this part of the chassis behind the cab is literally only the chassis. Like there's no extra bracing. Like a wagon, you know, obviously has the whole body to brace it, but a ute cab's essentially 2 separate pieces and the only thing that joins them is the chassis in the middle here. It's similar with dual cab chops, you know, they always tend to break the back of the chassis off and it's the same concept. You know, you have 2 separate parts and a lot of weight on the back and it gets a lot of movement and cracks the chassis. So by fixing the roof slider to the top of the rear hoop, that should help all of that. Now that's been done many times before. That's been, like I've seen that 15 years ago, but usually the roof sliders are welded on. So I'm a little bit concerned that there's only bolts holding that on. You know, obviously welding it to the roof is a lot stronger, but something that I'm just willing to try out. That's what I want to do. And if it works, that's awesome. If it doesn't, well, I'll know for next time. So I'll drag the bender back out and we'll get each side done and that will wrap this episode up. Well, that is one side roof slider finished off. What a nightmare. So I ended up with 4 bends in it. It looks a bit wild. So I've got a bend at the bottom here, a bend just above it on a different plane, a slight tweak along here on a different plane again, and then this top bend to run it across the roof there. So the plan with this is I'll put a cage joiner about here, I think. I need to do a little bit more thinking, but I'm pretty sure it's going to work well just there. And then this bottom section here, I'll trim this to length and then I'll weld this in and I'll put some bracing and that on it. So then this is just joined here. I'll have to orientate the joiner a certain way. So to pull it off, because it's got to slide out of the bracket at the top there, to pull it off, I can just slide it forward and it'll come out of this joiner. I was thinking of putting it here somewhere, but then with the guard on, you'd still have something coming through it. I sort of thought it would be cool to be able to unbolt it all and then it's potentially be able to cover it up and you wouldn't even know it's there. And the join onto the rear hoop worked out quite well. This is something I've been wanting to do since I built the race car, so it's cool to finally get that done. I just use a lower control arm end and it's still got the factory rubber bush in it, but I'll press that out and then I've got some nolithane bushes with the steel insert, so you can just slide them in and out because once it's all joined and connected on the roof side, it's going to be very hard to get it in the press to swap them bushes out because welding it destroys the bushes anyway, so I'll have to swap them out. And I'm very happy with how this turned out. It'll end up nice and strong once it's all finished, especially once the rear stays go on it. I've got some pretty cool ideas on the tray set up on how to store like camping gear efficiently, hopefully, but we'll cover that in a later episode when I build the tray. So doing all this was not easy. I took my time because I didn't want to waste the tube, obviously being so expensive. And other than some small offcuts, I haven't wasted any yet, which is quite surprising. So hopefully I can keep that up. I didn't allow any extra in case I stuffed up, so I don't really want to have to order more tube. So that wraps up this episode. Probably on the next one, we will do the other side roof slider, the whole external roof cage section. I've got light bar mounts to go on. I've got chassis bracing to do and a number of other little jobs. I've also got to make a start on this front end, which is going to be a massive job. If you've stayed this long in the episode, because I'm sure it's going to be long and boring, here's a little hint as to what's coming for the front end. So I don't want to show you too closely, but if you know what you're looking at, it should be pretty cool. But I hope you enjoyed this episode. I hope you learned something. It was a bit of a learning curve for me getting this done. I actually quite enjoyed the challenge. So thanks for watching and I'll catch you on the next one.